Today's learning target is are going to be able to factor quadratic expressions when a is not equal to 1. So we're going to go off of what we did last class, where we had our ax squared plus bx plus c equal to 0, and then we've kind of factored it down. Today I'm going to show you an algorithmic process. It's like steps 1, 2, 3, and it will work every time. You just cannot skip a step as you go through the process. First, let's remember how we solved by factoring. The first thing we have to do is we have to set the expression equal to 0. Because I'm missing a middle term, I know that that's a 0. I'm looking for two numbers that multiply to give me negative 16, add to give me 0. So I get 4 and negative 4. I then set each of my factors equal to 0 and solve, and I get my solutions right there. What are two other words or synonyms that mean roots? They could be x-intercepts, they could be solutions, or they could also be called zeros, and I will use those interchangeably as we go through this lecture today. So here's how we're going to do this. We are not going to guess and check. We are going to use what's called the grouping method. And I find it to be the most succinct, and it works every time, and it requires you to really know how to factor your GCF. So here's what I do. I set up an X marks the spot like we have been, but I have to multiply my A times my C. So I put A times C up here, which is 14. I put my B value down here, 9. I'm looking for two numbers that multiply to give me 14 and add to give me 9. 2 times 7 is 14, and 2 plus 7 is 9. So here's what I'm going to do. This is how it differs from our last lecture. Last lecture I was done at this point. Now I need to go back and I am going to rewrite that middle term, the 9x, I now break it out to 2x plus 7x. Once I'm here, I'm going to what's called group. I'm going to group my first two terms and my last two terms. Once I've grouped my first two terms, I'm going to factor out my GCF. What is common to both of those? It is 2x, and I'm left with x plus 1. And in the back, my GCF is 7. I'm going to factor that out. I'm also left with x plus 1. It is imperative, it is very important that these two match each other perfectly. If they don't, then I've done something wrong. I'm almost done. I then take this common factor, x plus 1, out, and what remains is my second factor, 2x plus 7. I now have a factored form of my original expression, my original function. It is now done in factored out. And if I want to check my work, I can just FOIL it back through to check to make sure I have the correct factors. Let's look at some more expressions here, okay? So in my first one here, I'm going to multiply my A times my C, and I get 20. I have a 12 down here. I need two numbers that multiply to give me my 20, right? Remember this was A times C, 4 times 5, and add to give me 12. I've got 2 and 10. And you can write it 10 and 2, 2 and 10. It really doesn't matter. Those are our two factors. I then come back here and I'm going to rewrite my middle term, right here, I just have 12u, but I've broken it out to 2u plus 10u. I then group my front two terms and my back two terms, and I think, okay, what's my GCF up front? It is 2u, and I'm left with 2u plus 1. In the back, I factor out my 5, and I'm left again with 2u plus 1. Remember, these terms have to match or I've done something wrong. I then take out that common factor of 2u plus 1. It represents one of my factors, and then what I have left over is my other factor, 2u plus 5. All right, let's do letter B. I'm going to multiply my a times my c to get 8, and then my middle term is negative 9. I'm looking for two terms or two numbers that multiply to give me 8 and add to give me negative 9. Got negative 8 and negative 1. I'm going to come back, make sure I separate this, and I'm going to rewrite my middle term as my negative 9x as negative 8x minus 1x. I then group my front two and my back two terms, and I'm going to take out my GCF that's common up front. Now I know that when I factor something out of here, I need to wind up with an x minus 2. So I'm going to factor out a negative 1, so I do get x minus 2 and x minus 2. I then take out that common term of x minus 2, and I'm left with 4x minus 1. So I now am down to my factors. And if I want to check again, I would just FOIL back on through to make sure I get the right answer. Let's look at letter C. We're going to just keep trying this over and over and over again. It's the best way to do it. I multiply my a times my c, and I get a negative 6. And then my middle term is negative 1. So I'm looking for two terms that multiply to give me a negative 6 and add to give me a negative 1. I've got negative 3 and positive 2. I'm going to come back and rewrite my expression. And then I'm going to group and see, okay, I've got this, I've got this. I'm going to factor out my GCF up front and my GCF in the back. And again, I'm double, triple checking that these two match each other. I factor out my p minus 1, and what I have left over is my second factor, 3p plus 2. If you're getting the hang of it, I recommend you pause and try this on your own. I'm going to keep chugging along here, looking for two numbers that multiply to give me a negative 21 and add to give me a negative 20. Got negative 21 and positive 1. So I come back and I'm going to rewrite that middle term. If you need that plus 1x as a reminder, it's always a good one to put in. I'm going to group my first two terms and my last two terms. I'm going to take out a 7x. Now this is a good one to do because I do not have anything that's common between these two. So I recommend taking out a 1 as kind of a placeholder so that it reminds you that it's there. I then factor out that common term of x minus 3, and I'm left with 7x plus 1. So I have now factored out this expression into its two terms. Right, let's look at this one. Let's see. 30, negative 13. I need two numbers that multiply to give me a 30 and add to give me a negative 13. Negative 10, negative 3. And I would double check that you have the exact same question for this one. I remember when I made this notes packet, I was trying to make sure that we had one that maybe was unfactorable. So double check that you have the same question in your notes that I do here. I'm going to factor out my GCF. And I need to do it in a way that makes sure that these here are exactly the same. I then factor out that common factor, and I'm left with 5x minus 3. And if I want to double check, and heck, I kind of do because I was worried that this was unfactorable to start, I'm going to go ahead and FOIL through to make sure I get back to our original question. And yep, lo and behold, that one worked out just fine. We have checked our work. All right, let's look at F. I have a negative 60 and a negative 7. So I'm looking for two numbers that are going to multiply through to give me a negative 60 and add to give me a negative 7. I have negative 12 and positive 5. I'm going to rewrite that middle term of negative 7x as negative 12x plus 5x. I'm going to take out the GCF up front. I then take out that common factor of x minus 2, and 6x plus 5 left over represents the other factor. So there are some things that we saw last time that now I'm hoping we can talk about the patterns and how to see them. So when we have what's called the difference of two perfect squares, I take the square root of what's up front. The square root of 4x squared is going to be 2x, so that goes in the front here. And I take the square root in the back, which is a 3. 1 becomes positive and 1 becomes negative. Now this only works if you have the difference, if you have a subtraction symbol. You have to be subtracting. I'm going to look at this next one. Same thing, I have a perfect square up front and a perfect square up back. So that is going to tell me that I take the square root of 9y squared, which is 3y, that goes up front. The square root of 49, that goes in the back. And because my middle term is a plus, these both become plus signs as well. Same thing for this last one. I see a perfect square up front and a perfect square in the back. I take the square root of what's up front, and that goes up front here, the square root of what's in the back, and that goes in the back here, and because my middle term is subtraction, those two become subtractions. Now, if you didn't see those patterns right away, you didn't see that they were perfect squares, don't worry. You can always do it the same way we've been doing it, where you set up your X marks the spot and solve the same way. I was just trying to show us that there are some patterns and therefore some shortcuts. All right, now we're going to throw kind of everything at us, where we have to look for GCFs and then keep factoring until we can't factor anymore. So I see a GCF in this one, so I'm going to take that out. I then see, and I kind of saw it before, right? We have a perfect square. 1 is a perfect square. So that tells me it's going to factor down as x plus 1, x minus 1. And like I said, if you don't see those factors or those patterns right away, don't worry about it. In my second one, I see another GCF. I'm going to make it a negative 3y. And when I do that, I have to make sure I change my sign. But notice how I no longer have a squared. So I am done. Sometimes just by taking out the GCF, you have completely factored the expression. Let's look at my next one. Let's take out a GCF here. And I know I like to work with a positive squared, so I'm going to take out a negative 2. And I'm left with 2m squared plus 5m minus 12. Notice my signs had to change because I took out a negative. Now I've got to go through the whole process. I don't have any perfect squares. I just have to go ahead and look for two numbers that multiply to give me a negative 24 and add to give me a 5. I've got 8 and negative 3. So I'm going to come back over here and rewrite my middle expression I am then going to factor out, right? I've got lots of different parentheses going on to keep everything straight. I'm going to take out my GCF here, my GCF in the back, again verifying that these are exactly the same. I am then going to take out the m plus 4, and I'm left with 2m minus 3. Whew, that was a doozy. There was a lot to that one. In letter D, I'm going to take out my GCF. And when I do that, notice I only have a 1z squared, which means I don't need to go through the whole process. Okay? Because I have a 1z squared, I can immediately jump down and realize that these numbers here are factors because I was working with a 1z squared. If I had a 2z squared or a 3z squared, I would have to keep going through the process. All right, for these last ones, I highly encourage you to pause the video, try these on your own, because you're not only factoring, you're also solving them. So for this first one, I notice I've got some perfect squares there. So these are gonna be one of our shortcut ones. Got a 5 and a 5, and because my middle term is a negative, these are also a negative. I'm then going to set each one of these equal to 0 and solve, and I get y equals 5/4 for both of them. So this function only has one x-intercept, and it's at 5/4. Let's look at our next one. Oh, I've got another perfect square. I also could have taken out a GCF, really. So a number of different ways to do this one. I put the square root of what's up front in the front, the square root of what's in back in the back, and I have a positive and a negative. I set those equal to 0, and I get negative 4/6, which I'm going to simplify down to negative 2/3. Positive 4/6, so I get a positive 2/3. So I get all the way down to my solutions, my roots, my zeros, my x-intercepts, all at once. Oh, same thing on this one. Got a nice square root here. So I got 2x minus 9, 2x plus 9. I get x equals positive 9/2, and x equals negative 9/2. All right, let's see, is this our last one here? Yep, here's our last one, and boy, is it a doozy, huh? Let's see if we can take out a GCF first. Now, I'm going to go ahead and set up my X marks the spot, right? I'm still going to have to go a little bit further here. Not done yet. Make sure I do my math right. Okay, we got 105. So I'm looking for two numbers that are going to multiply to give me a negative 105 and add to give me an 8. What do we got? Nope. Nope. 15 and 7. So I've got a positive 15 and a negative 7, right? And sometimes that comes up. You just got to kind of take your time and work through and think about all the different factors. I then do my grouping. I verify that those two are equal to each other. So my final factors are 5p minus 7 and p plus 3. I set each of those factors equal to 0, and I get one of my x-intercepts is negative 3, and my other one is 7/5. I know this was a lot today, but I promise you if you practice this, this will be a very strong fundamental skill that you will need in Algebra 2. Thanks.